Hello everyone. Welcome back to our channel. I'm so glad you could join us today. If you're interested in data science, machine learning, or just curious about how computers can learn from data, then you're in the right place. Today, we're diving into the fascinating world of support vector machines, or SVMs for short. So, grab a cup of coffee, sit back, and let's get started. Now, you might be wondering, what exactly is a support vector machine, and why should you care about it? Well, imagine you have a dataset with two types of objects, like apples and oranges. How would you teach a machine to distinguish between them? That's where SVMs come into play. To understand support vector machines, let's break it down into simpler terms. At its core, an SVM is a supervised machine learning algorithm used primarily for classification, though it can also be used for regression. The main idea behind SVM is to find a hyperplane that best separates the different classes in your dataset. So, what is a hyperplane? In two dimensions, it's simply a line that distinguishes between two classes. In three dimensions, it's a plane, and in higher dimensions, it's referred to as a hyperplane. The goal of the SVM is to find the optimal hyperplane that maximizes the margin between the two classes. Imagine you have a scatter plot with points representing apples and oranges. The SVM algorithm will analyze these points and draw a line that best separates them. But here's the catch, it doesn't just place the line anywhere, it tries to maximize the distance between the line and the nearest points of each class, which are called support vectors. These support vectors are crucial because if you only remove them, the hyperplane might change, affecting the model's accuracy. Now, let's consider a real-world example. Suppose we're trying to classify emails as either spam or not spam. Each email can be represented as a point in a multidimensional space, where each dimension represents different features, like the frequency of certain keywords, links, or the sender's address. An SVM will draw a hyperplane to separate the spam emails from the legitimate ones based on these features. But what happens if the data isn't linearly separable? This is where SVMs shine. They can use a technique called the kernel trick. The kernel trick allows us to transform the original feature space into a higher dimensional space where a hyperplane can effectively separate the classes. For instance, if we have a circular distribution of points for two classes, a linear separation wouldn't work. However, by applying a kernel function, we can transform this 2D data into a 3D space where a hyperplane can effectively separate the two classes. There are several types of kernel functions, including linear, polynomial, and radial basis function kernels. The choice of kernel can significantly impact the performance of the SVM, so it's essential to experiment with different kernels based on your dataset. One of the great advantages of SVMs is their ability to handle high-dimensional data effectively. This makes them particularly useful in fields like bioinformatics, image recognition, and text classification, where datasets can have thousands of features. However, like any algorithm, SVMs have their downsides. They can be computationally intensive, especially with large datasets. Also, tuning the parameters and choosing the right kernel can sometimes be a bit tricky, requiring cross-validation and experimentation. Despite these challenges, SVMs are widely used in the machine learning community due to their robustness and effectiveness in various applications. So, to summarize, a support vector machine is a powerful supervised learning algorithm that helps us classify data by finding the optimal hyperplane that separates different classes. It excels in high-dimensional spaces and can handle nonlinear relationships through the use of the kernel trick. If you're looking to get started with machine learning, understanding SVMs is a must. They're a foundational tool that can help you tackle a wide range of problems. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more educational content. Also, let us know in the comments if you have any questions about SVMs or if there's another topic you'd like us to cover. Until next time, keep exploring the world of data science and happy learning.